Today we're going to learn how to smooth 3D printed plastic with chemical vapors. So first, why is vapor smoothing a good idea? Well, there are three things really. There's the look, the strength, and mechanical surfaces. Vapors smooth parts. They look smooth and shiny. Since surfaces are now non-porous, they'll continue to look great for years to come. They're now easy to clean, and they won't harbor bacteria or fungus. Also, vapor smooth parts are stronger. FDM, or fused deposition modeling printing, results in layering, which means that parts are weak along the grain. But vapor smoothing makes the surface of your prints monolithic, so they're much stronger. Probably the biggest advantage, though, to vapor smoothing is that mechanical surfaces are made slick. This reduces noise and friction in mechanical devices and just makes them work better. So when I started printing, I printed in both PLA, here's PLA, and ABS, but I was getting really nice results using acetone as a solvent for ABS, so I pretty much abandoned PLA for a long time. I heard that tetrahydrofuran, or THF, works as a solvent for PLA, but THF is pretty expensive and it's not easy to find. But recently the author, Marnix, published an article on the Fabsterdam website about using ethyl acetate to smooth PLA prints. So ethyl acetate isn't too dangerous if you work in a well-ventilated area, and at $20 a liter, it is more expensive than acetone, which is about $5 a liter, or a little bit less than $20 a gallon. But it's much cheaper than THF, which comes out to about $50 a liter. So I should tell you, most brands and colors of ABS smooth very nicely, but some take a bit longer than others. So don't put different colors or brands in the same bath unless you know what you're doing. And you'll occasionally find a particular color of a particular brand that just doesn't work right. I have no idea about PLA, but I suspect the same is true, that some PLAs will smooth better than others. For best results, your prints should be pretty dense. Wall thickness should be at least 3 layers and at least 50% infill. With ABS, I go 4 or 5 layers and 80% infill to get very good results. Again, I don't know about PLA, but I suspect those prints should also have nice thick walls if you're going to vapor treat them. So we're going to make a cloud of plastic melting gas inside this pot with some printed parts inside. These chemicals boil at a much lower temperature than water, so just a little heat will give you the best results. I'm in my large and well-ventilated garage right now. The big rolling door is to my left, and the door to the backyard is open to my right. And there's a nice cross draft to carry fumes away. So please do work in a well-ventilated area. Take care not to inhale these chemicals, and always breathe through your nose so you can smell the vapors and run away if you have to. And volatile solvents are flammable. The vapors are very flammable, so keep open flames away from your setup. So for this setup, you'll need an electric pot with a basket and a glass lid. This is a Presto multi-cooker. I'm sure there are competing brands like Farberware or KitchenAid that make a similar item. This is normally a steam basket. The handle is detachable here. It comes off, and because the handle comes off, this lid fits nicely, so you get a nice seal around here. If your lid has a hole, and some of these lids will have a hole in it, cover that up. You can use a bit of blue tape or something like that, because you want the gases to stay inside during your vapor bath. This pot is just a shop tool now, so it'll never be used to cook food. That would not be a good idea. So I also bought a sheet of PTFE, which is Teflon, and I cut it into circles that fit in the bottom of the basket. You see I've got 4 here. I got a 12-inch by 12-inch sheet and cut it up. This is 1/32 or 1/32 inches. It's about 0.8 millimeters. So I can cut it with scissors. PTFE is kind of expensive, so I'm sure polypropylene or nylon would work just as well. So if you can get sheets of nylon or polypropylene, you can do that. It just has to be something that's not going to stick to this melted plastic. And of course you'll need solvent. We're talking about the two solvents we're using. I got acetone here from the hardware store. Now it comes in this awful tin. If you pour from this, it either you try to pour a little bit and it ends up splashing on this lip and goes all over the place, or else you try to go fast and you end up pouring way too much. So I keep acetone in a plastic gasoline container. This actually is acetone, and for a dispenser I use it's an old dish soap bottle, and it's made of it's number 2 plastic, and the flip top is polypropylene, so the acetone doesn't melt it, and it works great because it allows me to dispense small quantities into the cooker. The ethyl acetate that I bought comes in a much more sensible bottle. I could use this, but I still like the dish soap dispenser, so I've labeled this one. So I got lucky here and found that the polypropylene dispenser lid from the dish soap bottle actually fits on the ethyl acetate bottle. So there you go, I can actually squeeze it out of here. I'm going to do this in a single shot so you get an idea how long it takes. We'll start with the acetone and ABS. So right now this pot is cold. It's not. It hasn't been turned on, which is actually an ideal way to start. If I'm doing multiple runs, then I can't really achieve that each time if I'm in a hurry. But it's generally best practice to start with a totally cold pot, and then you just take some acetone and put it in the bottom. I'm going to use about 2 tablespoons. Yeah. Yeah, so that's about 30 milliliters. And then I can put this basket down in the bottom, and one of my PTFE sheets. Okay. And I've got a part here that I've printed that needs finishing, and I'm going to put that in there. And I've got, let's see, I've got, here's a proximal that could use finishing. Now if you're experimenting, like I said, I wouldn't put different colors of ABS in the same pot, because you'll find that some might be finished before others. Here's a red one. But I've got a sense of how long these are going to take. Well, I've got a sense that the red one's going to finish before this gray palm section. Maybe I should do that one separately. That's PLA. All right. So I've got these arranged. Now it's very important that that these are not touching. If they touch anywhere, then they'll be fused for life. They'll be stuck forever. Okay, so again, I haven't turned this on yet. I'm just going to put the lid on here. Okay, and this is where I turn it on. And I'm just going to turn it on to 250. And then you listen. And you might not hear it, but I'm listening for it to start boiling. And it won't take but a few seconds. Okay, I hear it starting to bubble there. So I'm going to turn it down just to warm here. And then you want to look in there, and you'll see all the layering will disappear. Everything will vitrify. Just doing that for a few seconds. Okay, and now I'm gonna turn it off now. Okay, so I've got a cloud of acetone vapor inside this pot. And it doesn't look really cloudy from the outside, but you can see all the parts, they all look glassy all over. Yeah, so I'm pretty happy with that. Alright. So that's about done. I'm going to take this out now. Oh, see, now you can see a bit of a cloud hanging in the bottom there. So let me pull this out, and you'll see everything looks all glassy. Alright. I'll just set it here for a few minutes. Make some room. There we go. And if you're smelling too much acetone, you can back off a little bit. Move away a little bit. Okay. So, now, if I touch these parts with my fingers, they're sticky. So what I'm going to do is, these actually have a little bit of a lip here. I'm going to lift this up carefully. And I can do this now because the plastic parts are kind of stuck to the PTFE. Not very well, but they're a little stuck to it. Stuck enough that they're not going to bounce all over the place when I take the thing out. So I would just leave it for a couple hours. After about 10 or 15 minutes, you'll be able to handle them. But don't squeeze them too hard, or you'll leave fingerprints on them. I'm just going to put this over on a board on the other side of the room here. But these should finish in a cool area is best. So I'm just going to put it over here on a shelf behind me. Okay, so that's one run there. Where'd I put the? Oh, here's the basket. Okay. So that's acetone. I'll do one more of acetone. So just put that in the bottom, and now there's already some acetone vapor in there. So there are two things I could do. I could try to arrange everything in here and then set it carefully down in the pot, and hopefully nothing will move around and end up touching each other because things are going to vitrify almost immediately with the cloud that's already in there. So I'll try that, but if things start to slide around, I'm going to need to back out. Here's a model here. This is kind of a princess. Usually I make prosthetics. That's what I print, but this is some kind of a test mold thing, or a test print. So put that on there. And I've got some other old prototypes here I can put in. So I don't see any acetone in the bottom of the pot anymore. So I'm going to put a little bit more down there. Okay. Then carefully lower this down. Yeah, because things are already starting to look shiny. Cover that up and turn it on a little bit. I'm going to turn it on to 200. Looks like things are already a little warm. And I can see if I look down in there, I can see the boiling acetone. Turn this down again. And now this is octave blue, which vitrifies very quickly. Okay. See, that princess sure looks shiny. Okay. All right. So there we go. There's another batch. So let me take this one out carefully and set it over on the shelf, and then we'll try a little with ethyl acetate and PLA. Let's see if I can lift up the edge of this. I've got a little bamboo skewer. Now if you leave these in a little bit longer than you needed to, then sometimes they'll kind of ooze plastic onto the surface underneath. And that's fine. I may need to take once I pull this off, there'll be a little edge on there. I'll just need to scrape off a little bit. But everything there is looking pretty slick and shiny. So I'll put this over on the shelf now. Okay, now for ethyl acetate. So I've got actually the same part you saw in ABS I also have in PLA. So that should be interesting to see. So the ethyl acetate works pretty much the same, but you don't have to use as much. I'd say maybe 20 milliliters, just a little bit more than a tablespoon per batch should work pretty well. If this is too hot, it's going to evaporate immediately. It's evaporating pretty quickly. So this pot's a little bit warm. It's not too bad anymore. It's not too hot anymore, I should say. So I'm going to try a batch of PLA with ethyl acetate. So here we go. Now here I'm putting in about 20 milliliters. Set the basket down there and start putting parts. That's a little warm, so you see I'm working quickly here. Oh, I want to get these long ones in here. Woohoo! Okay. Put the lid on there and warm it up. I'm just going to go 200 should be fine. Okay, that was bad. Okay, so you're witnessing a little bit of a disaster here. It's a good thing they're kind of dud prints. Because some of these parts are now touching. Okay. but everything is slick now. Alright, I'll leave it just a couple more seconds. Okay, here we go. All right. So this is why your parts should not be touching, right? Is they'll end up sticking like this, and this are stuck together now. And oh, I guess these two are not touching. So looks like some of my proximals got out alive. Oh, but they're not doing so well now. Okay, I'm gonna leave them a couple minutes. So I'm not sure if I left these in too long, or if it's just I should be using a different brand or color of PLA. I've got a little bit of you can see some little white marks showing up on there. So if you compare the results, the ABS really looks pretty and shiny. No doubt about it. The PLA, the mechanical surfaces are smooth, but it's not as shiny as ABS. But you can see that a good bit of the layering has disappeared, or has been smoothed off. So they should be mechanically superior to untreated. And here's untreated, and it's got a lot of layering, and a treated one, most of those layers have sort of melted off. While I've got you here, let me show you how to make cement for your ABS and PLA prints. So what you do is you take a polypropylene bottle, just like a medicine bottle, okay, and you put misprints, or you might have some support material, right? You can put that in there. This I'm going to make some orange, okay, and you pretty much put some plastic in there, and then you put the appropriate solvent. You just sort of squeeze some in there, and then close it up for a couple hours, and then you open it up and stir it. You got a little bamboo skewer or something, and you stir it until it's nice and smooth, and you can use that as cement, which you can either apply with a stick, but what I've had really good results with, I've got some ABS cement here that I recently mixed up, and you can get a syringe, just like this is just like a syringe medicine dispenser you would get at your local pharmacy, and you can actually use it to draw the cement inside. Okay, and then let's say I've got a little some little gaps in here I might want to fill in. I can do that with this. Just use it as a little glue dispenser and fill in any gaps. And if you use it to repair broken parts, it's very strong. It's in fact, it's stronger than the printed plastic. So you'll get great results. And of course, if it's PLA, you're going to put PLA parts in, and you're going to use ethyl acetate to melt it. But that should make a cement for you. And any of this that I'm not using, I can put back in the bottle, just like so. And then close the bottle up. And you don't really have to go to a lot of effort to clean this. because when the cement dries, it won't stick to the polypropylene. This is plastic polypropylene, but ABS won't stick to it. You'll just be able to break it off with your fingers, and there'll be a little plug in there that you just pull that thing out, and the plug will come right out. So I'll just leave that to dry. So here we are a couple days later. Although everything is pretty much the same as it was yesterday. After about a day, these things don't smell at all, and this is totally dried. Remember the little dispenser I use. So let me take the ABS. So all the acetone now has evaporated. So this plastic just breaks off. Pretty easily there. There it goes. So after 2 days, I guess that's still a little bit soft in there, but now it's pretty much a single plug. That must be why it's a little more difficult than usual to get this one out. But I could put a little acetone in there and wash it out now, or I don't need to use this one. I've got a spare, so I'll just leave that another day. A little bit will just knock out. So here are the same prints that you saw me treat. These are the ABS prints, and you can see here's a snap pin. You can actually also vapor treat these. I generally do. Here, let's pop this in so we can look at its mechanical function. There we go. And you can see that this opens and closes very smoothly. Those mechanical surfaces are all silky smooth. Now where this was sitting on the PTFE sheet, there's a little bit of a lip, and if you leave it in for a little long, you'll always get a little bit of a lip on the bottom. So I'm just taking the back of a knife and just scraping that down a little bit. I do say Her Majesty looks dazzling today. And here's the silver or gray. It really ends up looking silvery, and almost looks metallic now that it's finished like it is. Here's that little red proximal. And some other miscellaneous parts. So the ABS and acetone really is you can get very, very nice results. Now the PLA was a different story. It's so here's untreated PLA. Okay, and then here's the treated ones. Now you saw earlier that there's this white streak along here. Well, if you look at the back, there are these white spots, and now this is where it fell down against the PTFE. So it's really some awful marking, and I guess I could sand that off or something. I think it's happening where the air is trapped. So because this was down, the air was trapped underneath there, and you can see that the white streaks are actually in these kind of groove, crevice kind of formations. I'll get out the rest of this PLA. And it really seems that the more still the air is, the worse the worse it is. So you can see the little inside edge of these of the proximals got some of this white stuff, and that doesn't look too bad. Actually, on a finished device, you won't see that at all. So this proximal got off pretty well, and you can see the that the layering is mostly gone. So that's going to be pretty smooth mechanically. It's not perfect, and I think I printed this with fairly thin walls, so you'll want to print with thicker walls. And this is a very old print. I couldn't even tell you what company made this PLA, but these prints are like 2 years old, so you might not have the same problem, but I suspect you will, where it touches the bed and any crevices, you're going to see this white stuff. And on the proximals, I think it doesn't look bad where it kind of goes into these little crevices. It can kind of accentuate certain features, but like here's where it touched the bed, this particular proximal, and that's not nice in my opinion. And you probably agree. And here's the worst case, is this one here. Look at that. Oh no, right? So I'd sand that off. Maybe if I drop it in ethyl acetate for a little while and then turn it upright, that'll turn blue again. But it's almost like a kind of a chalky substance. Well, I can't scrape it off. It's a little too hard for that. But if you know what this is, put it in the comments below. Any chemists out there who can help me with this problem, your input would be very much appreciated, not just by me, but by many people. Because if we can perfect this process of smoothing PLA prints, that's going to help. It's going to help a lot of people do a lot of things that they need to do.